Hi, welcome to our 13th week of digital distance learning. This week, we are going to be working on volume. And that's it. That is the last week of final content. Next week, we're working on final projects and just closing out the school year. So all you need to do is survive one more week of new content and one more week of final project and closing. And you are free for the summer. But we're not there yet, so let's get started on volume. We have talked about perimeter, which is measured in units, because it is just length, it is one dimension. We have talked about area, which is measured in squared units, squared feet, squared meters, squared any unit really, yards, whatever you want. But that is because it is measured in length times width. It is multiplying two dimensions, and therefore we have to multiply the units as well. We have squared units. And finally, we are going to finish up the year in our world, the third dimensional world, length times width times height. That means volume is going to be measured in cubic units, cubic meters, cubic yards, cubic feet, cubic inches, always to the third power. Before we do, don't forget you need a piece of paper and something to write with so you can send me your notes. And of course, if you need anything, I am here for you. We have tutoring over the next 2 weeks, but you can always call me, text me, email me, whatever is most comfortable for you. Just get help. And that includes after the school year is over. Just because school ends doesn't mean your teachers disappear. We're always here for you. So make sure you reach out to us and let us know how you're doing. Bye. This is a cube. A cube has 6 sides. Its base is a square, and every other side of this solid is also a square. They have the exact same dimensions. I am going to get my measuring tape, and I am going to check the length. It looks like it is 5.5. So I am going to put 5.5 centimeters as my length. What about my height? My height is also 5.5, and that makes sense because this is a square. So the length and the height should be the same. What about the width? Well, when I check the width, and I realize it's upside down, I'm sorry, but it also is 5.5 centimeters. So we have a cube where each side, each dimension measures 5.5. Our formula for the cube is 5.5 cubed, and that means 5.5 times 5.5 times 5.5, or 5.5 times itself 3 times, which is 166.375 centimeters cubed. And you must maintain that cube because we have 3 dimensions, length, height, and width. Now let's talk about a cylinder. This is a cylinder. Its base is a circle, and then there is a parallel base that is also a circle. Let's take a look at a much more interesting cylinder. This is adobo, and I love adobo. If you cook, you know it's life. So let's take a look at the height of my adobo container. It is 17 centimeters. And again, upside down, I'm sorry, the diameter of my circular base is 6.4. Let's write down the dimensions. 17 centimeters is my height, the diameter right here, and it is 6.4 centimeters. Now that I have those 2 dimensions, those are our very 2 important dimensions, let's take a look at our formula for volume. Volume is equal to pi r squared h. Which makes sense. Pi r squared is the circle right here, the base, and then the height is going to be the other dimension that we need to take care of. Let's plug in some values. We have V equals pi times r squared, and we have to be careful here because r squared is not the same as the diameter square. I have found my diameter to be 6.4, and the radius must be half. Therefore, it must be 3.2. So let's write 3.2 squared. Well, the height is just 17. Let's find the exponent. 3.2 squared is 10.24, and we still have to multiply it by 17. When we do that, we get 174.1 pi centimeters cubed, or if we multiply pi, or times 3.14, that would be 546.9 centimeters cubed. And you can round differently if you would like. I have rounded to the nearest tenth. This is a cone. A cone is kind of like a cylinder, but it does not have a parallel circle. It only has one base. The other is a point. And the formula for the cone is the volume is 1/3 times pi r squared times h. Where does the 1/3 come from? Well, let's take a look at a cylinder again. If you cover the 1/3, this is the formula for the cylinder. And if you put the cone inside a cylinder with the same circular base, you can fit exactly 3 cones inside that one cylinder. So one cone is 1/3 of a cylinder with the same base. That is my base, the circle. It also must have the same height. But let's take a look at a more interesting cone. This is my funnel. This is my favorite funnel. And it has a diameter of 9.2 centimeters. It has a height, well, let's measure the height. Let's be careful. The height of the funnel does not include the long part, just the funnel itself, the circular container, and I have to measure it through the inside so that it is vertical. It creates a 90-degree angle with the base. That would be 7 centimeters. Now let's fill in some information. I have to figure out my radius. If my diameter is 9.2, I'm going to say that my radius is 9.2 divided by 2, and that will be equal to 4.6 centimeters. So my radius is 4.6, and I am going to square it, then multiply it by 7, which is my height. 1/3 times pi times 4.6 squared. 4.6 squared is 21.16 times 7, and it doesn't matter where you put the parentheses, they just denote multiplication. And now let's take a look and see if we can multiply 21.16 times 7, which gives me 148.12. And my final step here is remembering that 1/2 is dividing by 2 and 1/3 is dividing by 3. I'm just going to divide 148.12 divided by 3, and that gives me 49.4 pi cubic centimeters, or 155.11 cubic centimeters. Let's explore prisms. Here's a rectangular prism, or a box that has a rectangle as its base and another rectangular base parallel to it. This is a triangular prism. You can see one base is a triangle as well as the other, and the sides connecting it are really connecting the vertices of each of these bases. This forms the height on each side of the prism, which should be congruent on all sides. This box is a pentagonal prism because its bases are pentagons connected by the sides of the prism. And finally, this box is a hexagonal prism, which has 2 hexagons for bases. I'm going to get one box from my kitchen, and let's see if we can figure out the volume of this box. Here is my tea box, and here we are going to figure out the length of this box. It looks like it is 22.5 centimeters. Now let's consider the width. Well, to measure the width, I check here and it looks like I get 14 centimeters exactly. And finally, for my height, I get 7.3 centimeters. The volume formula for a prism is V equals capital B times H. Notice this is a capital B and not a lowercase b, because it is not the base, but rather the area of the base, the area of this rectangular base. We have to be really careful to make sure we have that. Of course, the height is the H. So let's figure out the area of the base. For the area of my box, I have length 22.5 and width 14 centimeters. Now let's consider length times width. That is 22.5 times 14. And that gives me an area of 310.5 centimeters squared, or squared centimeters rather. So I'm going to put 310.5 as my capital B. It is the area of the base, not the base itself. And then 7.3 is my height. When I multiply the two, I get the volume of my prism. If my prism were a triangle, then I would find the area of my base using the formula of a triangle. We notice here that we have cubic units, cubic centimeters, and that is because the area of the base was square centimeters, and we multiplied it by centimeters. Centimeters squared times centimeters is centimeters cubed. Pyramids are solids with one base and a point on top. As you can see, it has only one base. In this case, this is a square pyramid. Here's a triangular pyramid with a triangle base, and here is a pentagonal pyramid with a pentagonal base. No parallel base on top. The formula is volume is equal to 1/3 the area of the base times the height. Why 1/3? Well, just like with the cone, a pyramid is exactly 1/3 the volume of a prism, as long as the prism has the same base and the same height. Here is a triangular prism with the same base and the same height. You can see there is exactly enough space for 2 more pyramids, a total of 3. And the same thing happens with our pentagonal prism. If we have a pentagonal prism and I fit inside a pentagonal pyramid, I could fit 3 of them total. So now let's take a look at one specific pyramid, a really famous one. This is the Louvre, and I might be mispronouncing it because I do not speak French, but it is a very famous pyramid and one of the largest museums in the world, based on the Egyptian pyramids. The dimensions of the Louvre, 34 meters as each side of its base, and it is a square base, and then the height is 21.6 meters. Because it is our square base, I am going to use area equals S square, or 34 square, and 34 times 34 is 1,156 square meters. When I put it into my equation, I get V equals 1/3 times 1,156 times 21.6, which is the height. And when I multiply the area of the base times the height, I get 24,969.6, which is 8,323.2 when I divide it by 3. And I remember square meters times meters is cubic meters. This pyramid is based on the real Pyramid of Giza, which is a lot larger, 2,583,283 cubic meters. Let's consider a sphere. A sphere is a ball, and if you take a look at this, let's take a look at a half a sphere. What we see is that there is a circle in the center. It is essentially a circle all the way around, not just going sideways, but also going up and down, having that 3rd dimension, which is our height. And the formula for a sphere is 4/3 times pi r squared. Wait, scratch that. The height times pi r cubed. Remember, cubed because we're not just looking at the circle, but we're also looking at the height. Now, the 4/3 makes sense as well, but if you'd like to talk about it, let's talk during class. And let's take a look at the soccer ball. I'm going to try to figure out what is my diameter. Well, let's see, the diameter of this little one, I would just cut it in half and find it, but I can't seem to do that with my soccer ball. So how about I find the circumference and use that for my diameter? I think I can do that. I'm going to wrap the measuring tape around the ball until I find my circumference, which is 68 centimeters. Stay. Okay, so V equals 4/3 times pi times, I don't know what r is, so let's figure out. C equals 2 pi r, my circumference is 2 pi r, where C is 68. And I'm going to divide by 2 pi on both sides, and that gives me 10.8 centimeters. Notice that that is not 34 pi, but rather 34 divided by pi if you want to leave it in pi terms. But I think it's easier as a decimal, so I'm going to write 10.8. I'm not going to forget the cube, because it is not just 10.8, but rather 10.8 in every direction, length, width, and height. And 10.8 times 10.8 times 10.8 is 1,259.7. I am going to multiply the top and then divide by 3. 4 times 1,259.7 is 5,038.8 pi. And divided by 3, I get my volume, which is 1,679.6 pi cubic centimeters, or I can also multiply by pi, and when I do that, I get 5,276.6 cubic centimeters. Both of these answers are correct.